Hi, welcome to a Double Witch Wednesday. I hope you're ready for a double serving of some mathematics on today, this wonderful Wednesday, the 26th. And thank you for showing up for your learning. So, for those of you who are here in the flesh, you can please get out your quadratic formula note and we can take a look at this main tool that we're going to be using in a variety of ways to conquer quadratic equations in this unit. Okay? If you were to get a mathematics tattoo, a tattoo related to mathematics, I don't encourage you to get tattoos. I am undecorated myself, but if I did, it might be the quadratic formula. Or I'll also have been thinking about making those temporary tattoos with the quadratic formula on it. That way you can put one on for test day, and no one can tell you to take that away because it's you can say I got a tattoo. How can you tell me to put my tattoo away? Oh, your tattoo gives you an unfair advantage. Well, yeah. Okay, so let's go. Our main goal is that we're able to find the roots of a quadratic equation using the quadratic formula. And just to review, a quadratic equation might look like f of x is equal to like something like 3x squared plus 6x. And then if we look at this quadratic equation, we want to remember what we mean by roots. So roots here are also called the zeros because y equals 0 all along this line, the x-axis. So that's where the output of the function has a value of 0. And then we call them also solutions to quadratic equations and x-intercepts. So there's really 4 different words that we'll use here. And to be honest, the word that I used really depends on my mood that day. So you got to kind of know all of them. All right, let's take a look. So if we wanted to solve this type of equation, f of x is equal to x squared minus 8x plus 15, and we want to know where does that equal 0, well, we would take that, and last unit we would have written it this way: 0 equals x squared minus 8x plus 15. And then, is there a way that we can solve that without the quadratic formula? Can you find for me two numbers? They multiply to positive 15, add to negative 8. What flavors of 5 and 3? X minus 5, x minus 3 will do it. Notice that if we decide to expand that back out using FOIL, we're going to have x times x is equal to x squared. X times minus 3 is minus 3x. Minus 5 times x is minus 5x. And minus 5 times minus 3 is plus 15. So that's why we were looking for numbers that added to 8 and multiplied to 15. But really the important and the interesting thing was happening on this line here, where it allows us to spot the values for x that make this equation equal to 0. Going back to my briefcases full of cash example, if briefcases exist and there is some amount of cash in these briefcases, if you have $0, you either have 0 briefcases or there's 0 cash in each of your briefcases. One of those two things must be true for you to have $0. So in this case, either x plus minus 5 equals 0 or x minus 3 equals 0. This one solves by adding 5 to both sides. And that gives us x equals 5 as one of the solutions. This one solves by adding 3 to both sides to get x equals 3. And so there are our two solutions. We can solve these things by factoring if factoring is available. Factoring is not always available to us. And in those cases, it's not. We have the quadratic formula. If I ask you to find where this one is equal to 0, you would say, well, 0 equals x squared minus 5x minus 1. And then you would say, well, there's no numbers that multiply to negative 1 and also add to negative 5. We don't know what these numbers are. Let's take a look at this in Desmos, and we'll see what it looks like. So we had x squared minus 5x minus 1. And so we see that there are indeed two spots where it's touching the y-axis, but these aren't integers. They're not clean, nice, well-behaved points. They're really ugly looking fellows. So how are we going to find those? Again, we'll use a quadratic formula to find these types of answers. So there does exist a formula that will give us the roots when you have this situation, ax squared plus bx plus c equals 0. Okay? If you are looking to solve that situation, even if the equation is factorable, you can always use the quadratic formula. Always. To find out what the solutions are, or even if solutions exist. Who has the quadratic formula off the top of their head? Anybody? Yeah. Anyone? Oh, let me just check my tattoo. I have a tattoo in my brain. And I'm going to tattoo it in all of your brains by playing this song twice today and once a day for like the next few days. All right? So here we go. The quadratic formula song is going to change your life. All I ask is that you sing along for the chorus and do an interpretive dance. It's not much. There it is. Okay. So with that earworm firmly entrenched in your head, and I'll be singing that quite regularly. Just about every time I write it down, I sing that one. So what do we need? We need to get that equation onto our sheet, into our notes, and to, if we can, even better, commit it to memory. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. What should you do if you forget the quadratic formula? You should just fail the test. Yeah. Well, I give you the chance to have a cheat sheet, right? You think your cheat sheet should include that? Maybe, yeah, maybe yes. Sometimes I try and sneak it onto a test, like as part of a multiple choice question or something like that, to help you out. But also, you can sing the song. Sing the song can help. Or Google it if you're not in the middle of a test. Just Google the thing. Practice looking it up and solve your own questions. So let's go. So now let's say we want to find these fellows here, these points where this equation is touching the y-axis. We want to find those without graphing, without using the graphing calculator. Let's try it with the quadratic formula. So here, this is what I recommend you do when using the quadratic formula. And I'm going to use this area up here for my rough work. This should be a little higher. Is make a little chart. And your chart looks like this. A equals, B equals, C equals. Write this out every time you use the quadratic formula. I promise it will help you make fewer errors. I do this. I do this all the time. I make a little chart. Here I notice my A. Oh, I don't see an A. Is it 0? No, it's not 0. It's 1. Okay, because that's 1 times x squared. I'm 1 times 42 years old. It's a very strange way of telling my age. But it's still there, 1. And then here, minus 5. That's our B. Not 5, minus 5. And then C, minus 1. So I find my A, my B, and my C, and put them in a little chart. And then the next step, and again, I promise, if you do this step, you will make fewer errors. Copy out the formula every time. It will also help you to remember the formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. There. You can sing along as you do it. I promise you won't forget this for the rest of your life if you remember that song. And then now you go ahead and substitute into this formula. This is going to be so much of this unit. Substituting accurately and avoiding sign errors will be a big part of this unit. It's an excellent workout for your accuracy muscles, your algebraic accuracy, the quadratic formula. So I know x is going to be equal to, well, go ahead and find b. B is negative 5. And you can write this down one of two ways. You can write negative 5, and that's good. That will be positive 5. Or you could just sub it in and flip the sign. Write positive 5. I like this. It's pretty good. So negative b, so that's negative 5, plus or minus the square root. So I have plus or minus the square root b squared. So I'm going to write in negative 5. Put that in brackets. Always substitute into brackets. Without the brackets, negative and then 5 squared means the negative doesn't get squared. Your calculator would tell you negative 25. We actually want positive 25 here. Negative 5 times negative 5. It's positive 25. Minus 4ac. Minus 4 multiplied by a. You can substitute 1 in there if you want. You don't have to, because multiplying by 1 is just 1. And then multiply by c. C is negative 1. There we go. Draw the fraction bar, and then have your 2a on the bottom. 2 times 1. And now we simplify. We need to start simplifying inside the square root first. So let's do that. This can simplify outside here. Negative 5 is just positive 5. Plus or minus the square root of 25 minus 4 times negative 1. So in this case, notice that you have a negative times a negative. That will make it a positive. Plus 4. All divided by 2 times 1 is 2. Okay. And so now we have x equals 5 plus or minus the square root of 29 over 2. Now, how do you punch that on your calculator? Bennett, are you able to punch these on your calculator, get the correct answers? 5 plus or minus the square root of 29 over 2. So this is actually done final answer, but I don't really know where to put that on the number line. I don't have a good sense of what that number means. So I do want to do a decimal version of it and find an approximation on my calculator. That's all the Desmos is giving us as well, is just an approximation. So taking a look at that, the square root of 29, it's going to be between 5 and 6. So something like about 5.3, let's say. And then if I do 5 minus that, I'll have a little bit less than 0 divided by 2. I'll have a very small negative number. If I do 5 plus that, I'll have a number like 10 divided by 2, but a little bit bigger than 10. So I expect something a little bit bigger than 5. Something a little bit smaller than 0 and something a little bit bigger than 5 would be my expectations. Let's see what we have here. Oh, there's my number a little bit smaller than 0. There's my number a little bit bigger than 5. And I start with like a bit of an error check like that because I can make chubby finger mistakes when I punch these into my calculator. You want to have a general guess of where these numbers are and what kind of thing you're going to expect. So, yeah, that's that example. Now, how do I know that the square root of 29 is between 5 and 6? Can anyone tell me why I know that square root of 29 is 5 and a bit? Tyler?
Because 5 times 5 is 25, so
Yep. So it's going to be bigger than that. But why would I know it's less than 6?
because math.
Yeah, because of the math. The math shows me 6 times 6 is 36. 36 is bigger than 29. 25 is less than 29. So I know it's going to be between those two integers. Here's what I kind of have in my head. The square root of 25 is equal to 5. And that's going to be less than the square root of 29, which is going to be less than the square root of 36, which is equal to 6. So I know 29 is in between 5 and 6. Sorry, the square root of 29 is between 5 and 6. This kind of thing is happening in my head. And because I have a good memory for these numbers, well, maybe that would be another nice math tattoo to have on your body somewhere, but you need it like, I don't know, the back of your hand, it would be so small, you might need it up there. But then if you, okay, I'm not recommending math tattoos. That's enough of that. Let's keep going. Look at some more examples. So make a little chart. Oh, that was where I want to do my rough work. No wonder. Okay, so anyway, carry on. All right, so the solutions to these quadratic equations, they're often rational numbers. If they're not, then we could have factored it. So let's try actually doing this same idea with a, b, and c here with this quadratic equation that we just factored. And let's see what happens when you use one that's factorable. All right, so my a is 1, my b is -1, -8, and my c is 15. Evaluate. So here we go. X is equal to -b plus or minus the square root of b squared minus 4ac over 2a. All right, let's go. This is equal to -b, so I'm just going to write 8. I could write -8 plus or minus the square root of -8. So I'm going to write 64 minus 4ac. So a is 1, c is 15. So this is minus 4 times 15 all over 2a, which is 2. Well, why is 8 positive? Because we want -b, but b was -8. So -8 is +8. Yeah, like -8 is just -8, but -8 is +8. -8 would be -8. -8 would be +8. You count your negatives. If it's an even number of negatives, then it's a positive. If it's an odd number of negatives, sorry?
Can I do that like my money?
With your money?
Well, if I'm in debt, $1 million, and I put another negative on it, positive.
Yeah. So let's just, how about we multiply my money by -1? Yeah, yeah, that would be fun. Okay, so let's see what happens when we evaluate this. This is equal to 8 plus or minus the square root of 2 over 2. Sorry, 8 plus or minus the square root of 4. Not 4, not 2, 4. Because 64 minus 4 times 15, well, 4 times 15 is 60. So this is 8 plus or minus the square root of 4. And so that's either equal to 6 over 2 or 10 over 2. And we found that this was actually equal to x minus 3 times x minus 5. So that was telling us that x is equal to 3 or x is equal to 5. And we remember that if we're factoring, gentlemen, I recognize I'm talking over you, but I'm about to drop a knowledge bomb that might save you some marks on a test. So watch this one. Notice that when we factored x squared minus 8x plus 15, actually you factored it, you guys, x minus 3, x minus 5, that we flipped those signs to find that x is equal to 3 or 5, not -3 and -5. That was by factoring. With the quadratic formula, it outputs 6 over 2 or 10 over 2 which are saying, well, that's saying 3 or 5 by another way, these do not need to have their signs flipped. The quadratic formula is just outputting what the values of x are when that function is equal to 0. So don't be flipping the signs of those. So let's try with each of these. So go ahead and use the quadratic formula and solve for x in these cases. There you go. Yeah, so this is with a factorable one. Notice that it came out to the square root of 4 was inside the brackets. And the square root of 4 is something we can calculate. It's like it's 2. Well, we can calculate any of them, but that one calculates without creating an irrational number, a number with a weird decimal that has no repeats in it. This one is just 2. And when you see that, actually the quadratic that you were looking at was factorable. We could have solved it by factoring. Okay, so with these, start with changing the pen color each time. And we make a little chart, A, B, and C. Your A here is equal to 2. Your B is equal to -9. And your C is equal to 1. Okay. So let's go. So this one here will be, and then you again always copy it. X is equal to -b plus or minus the square root of b squared minus 4ac over 2a. And then just substitute carefully. X is equal to -b, so that's, hey Tyler, -9, +9. Yeah. 9 plus or minus b squared. So I can put an 81, or I can write -9 squared. That's fine. 81 minus 4 times a times c. 4 times a. Oops. I should do 2 times c, which is 1. All over 2 times 2. Okay. That's going to equal 81 minus 8, 73. So this is 9 plus or minus the square root of 73 over 4. Okay? And now, once we've gotten that into the fully simplified form, we can make a guess about what those numbers are going to be and then calculate. The square root of 73, about what number is that? Yeah, like pretty close to 8.5. Yeah, something like 8.5. It's 8 and a bit, because 8 squared is 64, 9 squared is 81, 73 is in between those two things, so it's going to be like 8 and a bit. And by doing this little check, not only are you going to find errors if you punch something wrong on your calculator, you're also building your number sense. So it's good to have these little checks built into your math process. Helps your learning. So I have 9 plus or minus a bit, like 8 and a bit. If I did 9 minus 8 and a bit, I'd get a number like between 0 and 1. And then I go ahead and divide that number by 4. I'm going to have a number very close to 0 but non-zero. Something just a little bit bigger than 0. And then, if I did 9 plus 8 and a bit, I'd have 17 and a bit. And then I go ahead and divide that by 4, I'll have a number a little bit bigger than 4. Somewhere around like 4.25, something like that. So let's take a look at what this looks like in Desmos. 2x squared minus 9x plus 1. Do I recommend that you actually sub these all into Desmos and take a look? Absolutely, I do. What was it? 2x squared minus 9x minus 1. Was that it? No, it wasn't. It was plus 1. Plus 1. Yeah, because that doesn't have what we predicted. Plus 1. There. There's my number very close to 0, but not quite 0. There's my number a little bit bigger than 4. So I'm not surprised. Why is it not showing over here? That's so weird. That's so strange. It's like frozen there for some strange reason. Huh, on the projector, you're not seeing it. Reload. Super weird. Okay, anyway, I'll show you again. 2x squared minus 9x plus 1. So there. Here's the number a little bit bigger than 0. Here's the number a little bit bigger than 4. That's what we would have predicted. And let's just show you evaluating this with your calculator. 9 plus or minus the square root of 73 over 4. So you get your calculator out. Move it over. You would do, I would use brackets on my calculator. Bracket 9 plus 73. But I take the square root of 73 and the bracket and then divide by 4 equals. So there's one of them, 4.386. Depending on how many decimal places I want, I might call that 4.4. So I might say x equals 4.4, or, and then I get another solution. I get two solutions because of the plus minus. And I'm getting two solutions because of the shape of these quadratics. There are two values for x frequently that give me a solution. And the quadratic formula points you in both directions with the plus minus. So the other one, you would do, what was it? 9 minus the square root of 73, but a square root equals, and then divide that by 4. Divide by 4 equals, and there's this number, 113,999. That's 114. That's my number. That's my root here, 114. 0.114. And I could say that's 0.1. If I wanted just one decimal place, those would be the correct answers. And on tests and things, I'll give you instructions as to how many decimal places to include. With something like this, again, make a little chart. Have your A, your B, and your C. Here my A is 1, my B is negative 6, and my C is negative 27. So let's try this. X is equal to negative B plus or minus the square root of B squared minus 4AC over 2A. In this case, I put in negative 6 plus or minus the square root of negative 6 in brackets squared minus 4 times 1, which is A, times negative 27, which is C, all over 2A, which is 2 times 1. Simplify. Negative 6 is positive 6, plus or minus square root of 36 minus 4 times minus 27 gives me plus 108. 36 plus 108 all over 2. Okay. 36 plus 108 is 144. This one was factorable. Yeah. 6 plus or minus the square root of 144 over 2. So the square root of 144, what's that? What number is the square root of 144 going to be between? Trick question. Yeah, it's 12. Good number sense. So 12 squared is 144. So the square root of 144 is 12. So this one was factorable. And if we look at it, yeah, it was. Negative 9 times positive 3 would be negative 27 and would add to negative 6. So we could have solved this by factoring. But we didn't. We used quadratic formula. Hooray for us. So this is equal to 6 plus or minus 12 over 2. 6 plus or minus 12 over 2. Let's do that. 6 plus 12 is 18. 18 over 2 is 9, positive 9. And then 6 minus 12 is negative 6 over 2 is negative 3. So x equals 9, or x equals negative 3. Cool. Sorry, the 9? 6 plus 9 over 2. Sorry, 6 plus 12 over 2. 6 plus 12, 18. 18 divided by 2, 9. Yeah. And then 6 minus 12, negative 6, divided by 2, negative 3. Skipped some steps there. Now, one last thing to note, and this comes up in your textbook problems. If you have an equation that's not equal to 0, you have to follow the instructions in the video which are move all the stuff to one side so that you have it equal to 0. My first step here would be to say, well, this is not an equation equal to 0, so I'm going to add 3x squared to both sides and add 8x to both sides. Ask me why I didn't subtract 5 from both sides.
I'd rather not.
I could have, but then all of my numbers would have been negative.
Yeah, well, that's fine.
I could do that and then multiply both sides by -1 and solve that problem.
Yeah.
Then I'll confuse people. So then I get an equation that's 0 is equal to 3x squared plus 8x plus 5. Okay? And this one, we would just use the quadratic formula now. This is the form you need to apply quadratic formula. It must be set to 0. It must be equal to 0. So if you have a problem where it's not, shove everything to one side with your inverse algebraic expressions and then go. Okay, so that's it for the lesson. I hope you got a good note and got the song in your head. The unit outline is here, and we'll just zoom in on the practice problems in the textbook there, and I'll freeze the screen. You can see them here, and they're also in the D2L. Any questions and your team learn at home, hit me up by email. Bye for now, everyone.